Let's talk about the trigonometric ratios. There are 6 trigonometric ratios, and they're all based on the relationships between 2 out of the 3 sides of a right triangle. I'll label the 3 sides of this triangle A, B, and C. This is how you're used to seeing a right triangle labeled because we know the Pythagorean theorem, c squared equals a squared plus b squared, and we usually label the hypotenuse c. This isn't about the Pythagorean theorem, though. Today we're going to be talking about the trigonometric ratios, which means we're going to be talking about the relationships between these 2 sides, these 2 sides, and these 2 sides. So I can say, for example, that there is a relationship, a ratio between the length of side A and the length of side C, the length of side B and the length of side C, and the length of side A and the length of side B. And then, of course, I can say that the ratio between the lengths of sides C and A, C and B, B and A also apply, because these are different from the first ratios that we defined. For consistency's sake, we want names for these ratios. Conventionally, we call these ratios sine, cosine, tangent, cosecant, secant, and cotangent. An important observation here is that the hypotenuse is always the hypotenuse, but A is the short side and B is the long side in my triangle, but it might be the other way around. So we need a way to sort of anchor these relationships as well. And for that reason, we're going to say that A over C is the sine of the angle theta. Now sometimes you'll see alpha or phi. Sometimes you'll see the capital letter A used for the name of that angle. But it's pretty conventional also to use the Greek letter theta as the variable when we're talking about an angle. So now I can say that the sine of the angle theta is A over C. Why is that important? Well, if I was looking at it from a different perspective, say the other angle up here, and I'm going to use the Greek letter phi for that one, then to say that the sine of phi was A over C would be confusing. You see, in relation to the angle theta, A is the side opposite that angle. But in relation to the angle phi, A is the side next to the angle. So the sine of an angle is going to depend on where that angle is in relation to the sides, or perhaps more accurately, where the sides are in relation to the angle. So we say that the sine of theta is A over C because A is opposite the angle theta and C is the hypotenuse. And to apply this to the sine of phi, we would have to find the side opposite phi and put that over the hypotenuse. Well, in that case, the side opposite phi is B, and the hypotenuse is still C. So it's not entirely accurate to say that the sine is always A over C. The sine of an angle is the side opposite that angle over the hypotenuse of the right triangle it's in. Likewise, the cosine is always going to be the side next to the angle. So I can't just talk about sine and cosine and tangent. I have to talk about the sine of theta or the cosine of phi Let's clear the board and I'll show you what I mean. So now when I talk about the sine, I'm going to be talking about the sine of an angle. And that's going to help me determine what that particular sine is. The sine of theta is A over C, because A is the side opposite theta and C is the hypotenuse. The sine of phi, on the other hand, is B over C, because B is the side opposite phi and C is the hypotenuse. What about our right angle? Does that have a sine? Let's take a look. For one thing, we know it's 90 degrees, or pi radians. What would the sine of pi, or the sine of 90 degrees, be equal to? Well, the sine is the opposite over the hypotenuse, which is also C. So the sine of 90 degrees, a very special case, is 1. That's worth remembering. We're going to need it in the future. Okay, there's been a lot of talk about sine, but what about the other 5 ratios? Well, we've established that sine is opposite over hypotenuse. For any angle in a right angle triangle, the sine of that angle is the length of the side opposite that angle over the length of the hypotenuse. You'll often see that written as sine theta equals O over H, opposite over hypotenuse. Before we talk about the other ratios, I'd like to make an observation here. I've been talking about sine, but I've only been writing SIN. Here's a side note. Sine is written like this, and it's abbreviated SIN. Cosine is abbreviated COS. Tangent is abbreviated TAN. Those seem pretty obvious. Let's take a look at the other 3. We have cotangent, secant, and cosecant. The first 3 ratios just use the first 3 letters, SIN for sine, COS for cosine, TAN for tangent. Cotangent and secant get away with the same strategy. We just use COT for cotangent and SEC for secant. With cosecant, though, we run into problems because we've already used the abbreviation COS to mean something else. So for cosecant, we're going to use CSC, cosecant. Okay, one more thing before we go on here, and this is important. I can talk about the idea of sine because we now know that what that means is that for some angle, its sine is the ratio of the lengths of the 2 sides, the opposite and the hypotenuse. But to see sine written this way by itself doesn't make sense. In order to talk about sine, I need to talk about the sine of an angle. I need to talk about the cosine of an angle, and so on. And so especially when you see these terms abbreviated, they should also include an angle name. Now, sometimes that angle isn't always theta. In our case, for example, we might be talking about the cotangent of angle phi instead of theta. What matters here, though, is that we recognize that in order to talk about a sine or a cosecant at all, it must be the sine of an angle or the cosecant of an angle. If I just write tan, that's essentially meaningless. Okay, so now that we've established that we need an angle in order to take the sine of that angle, And we've established that once we know the angle, we can determine its sine by taking the side opposite and the hypotenuse and finding the ratio of those two sides. And that's how we define the sine of theta. So if sine is opposite over hypotenuse, how are the other 5 ratios defined? What particular order do we need to look at those ratios in? I've moved things around a bit so that when we're done here, we'll have a nice record of all 6 of the trigonometric ratios. Let's just go through the rest of the list, and then once we have all 6 definitions, I'll go back and we'll do a couple of examples. The cosine of an angle is defined as the side next to the angle, which we call adjacent, over the hypotenuse. So in the case of theta, we have the cosine of theta would be b, adjacent, over c, the hypotenuse. The tangent is defined as the length of the side opposite the angle theta divided by the length of the side adjacent or next to the angle theta. That's all the possible combinations of opposite, adjacent, and hypotenuse if you don't care about the order of those combinations. But recognize that while the sine is the opposite over hypotenuse, we might also want to talk about the ratio between the hypotenuse and the opposite, for example. And so we need a special word for that as well. And that's where the other 3 ratios come in. The cotangent is the reciprocal of the tangent. So since tangent is opposite over adjacent, cotangent is adjacent over opposite. The secant is the hypotenuse over the adjacent, and the cosecant is the hypotenuse over the opposite. And you can check for yourself, but this is all possible combinations of opposite, adjacent, and hypotenuse, including all the possible different orders that those can come in. Okay, so here's the same triangle again, but this time instead of generic side lengths A, B, and C, I've given the side lengths 3, 4, and 5. Let's take a look at what it means to be the sine of an angle theta in a triangle with sides 3, 4, and 5. The sine is the opposite over the hypotenuse, and by that we mean the length of the side opposite the angle over the hypotenuse of the triangle. So in this case, that would be 3 over 5, because the 3 is the length of the side opposite the angle in question. The cosine of theta is 4 over 5 because cosine is adjacent over hypotenuse, and adjacent just means next to. When we say that adjacent means next to, we mean next to the angle but not the hypotenuse. Technically, the hypotenuse is also adjacent to angle theta, but we use the word adjacent to distinguish it from the side opposite. Okay, let's take a look at the rest of these. The tangent of theta is the opposite over the adjacent, the side opposite the angle theta over the side adjacent the angle theta, or the lengths of those two sides anyway. The length of the side opposite theta is 3, and the length of the side adjacent to theta is 4. Cotangent is adjacent over opposite. The length of the side adjacent to theta is 4, and the length of the side opposite is 3. Secant is hypotenuse over adjacent, so we have 5, the hypotenuse, over 4, the adjacent. And cosecant is hypotenuse over opposite, so we have the hypotenuse, 5, over the opposite, 3. Now let's look at these ratios from a different angle, and I mean that literally. The other non-right angle in this triangle I have labeled phi. The sine of phi is also opposite over hypotenuse, but from the perspective of phi, the side opposite that angle is 4. So opposite over hypotenuse is 4 over 5. Cosine is adjacent over hypotenuse, so from this perspective here, The cosine is 3 over 5. The cosine of phi is 3 over 5. The tangent of phi is opposite over adjacent, or from phi's perspective, 4 over 3. The cotangent is adjacent over opposite, which is 3 over 4. The secant, hypotenuse over adjacent, is 5 over 3. And the cosecant is hypotenuse over opposite, or 5 over 4. It's interesting to note that the sine of theta and the cosine of phi have the same value. The cosine of theta and the sine of phi have the same value. The same is true for the tangent of theta and the cotangent of phi, and the cotangent of theta and the tangent of phi. The secant of theta and the cosecant of phi are the same, and so are the cosecant of theta and the secant of phi. This is actually why these ratios have the names that they do. The sine and the cosine are called cofunctions. They have the same value depending on which perspective you're looking at the problem from. From the perspective of theta, the sine is 3 over 5. From theta's co-angle, phi, the cosine is 3 over 5. Okay, just one last thing for this video. Let's take a look at sine, cosine, and tangent in a slightly different perspective. I'm going to make copies of my sine, cosine, and tangent. And then I'm going to erase the sine, cosine, and tangent that I have over here. I'm going to leave cotangent, secant, and cosecant for the moment, but I want to leave them there as a reference for right now, because I want to look at sine, cosine, and tangent and how they're related to the other three. We've already talked about how sine and cosine are related, tangent and cotangent, and secant and cosecant. How does sine relate to cotangent, secant, or cosecant? How does cosine relate to cotangent, secant, or cosecant? And here's what I mean by that. Let's make the observation that since tangent is opposite over adjacent and cotangent is adjacent over opposite, let's write cotangent here. Cotangent of theta equals adjacent over opposite. Cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. So I'll write that one here next to the cosine. And lastly, sine is opposite over hypotenuse, but cosecant is hypotenuse over opposite. All right, now I'll erase those other ones. We don't need two copies of those. But I've written them in a different order, and here's why. One of the things we'll be doing in this class eventually is learning how to write one trigonometric ratio in terms of another. And it's really useful and very helpful to recognize the specific relationship these ratios have with each other. In other words, each one of these is a reciprocal of one of the others. So when I write down my list of ratios, I always write them in this order: sine, and then cosine, and then tangent, and then going up from the bottom, cotangent, secant, and then cosecant. And the reason for that is that it helps me to remember cosine, for example, is just 1 over secant. Here, let me show you what I mean. 1 over the secant of theta is 1 over, well, we've said that secant is hypotenuse over adjacent, so I'll write that as a fraction. Now, 1 over hypotenuse over adjacent just means 1 divided by hypotenuse over adjacent, and that's 1 times adjacent over hypotenuse, and that's just cosine. So a little bit of algebra magic here gives us the relationship between secant and cosecant without having necessarily to go through the adjacent over hypotenuse, hypotenuse over adjacent. These are called reciprocal identities, and we'll talk a lot more about identities later in the quarter. But once we get there, we'll be able to say, well, we already know the reciprocal identities, and that's just less to learn. To summarize what we've been talking about today, we've been looking at relationships. Relationships between the lengths of two sides of a right triangle. Relationships between co-functions. And relationships between reciprocal functions. These things are all connected, in this case in different ways. But that sort of wraps up and summarizes everything that you need to know about how to define the 6 trigonometric ratios and how they're related to each other. If you have any questions about this video, please leave them in the comments.